All right, hello. Why do flamingos only lift one leg? Because they surely can't lift up two at the same time. They'll fall down. Duh. All right, here we go. We have got another one for you guys. Today we are talking specifically about the trapezoidal rule. Okay. Now the trapezoidal rule, kind of in the name, we use trapeziums. But what it is, the most important part here is recognizing that the trapezoidal rule gives us an approximation of area. Okay. Um, and yeah, essentially we use this when there's curves because we don't have a real good way to um, we don't have a real good way to find areas of shapes with curves, so we can approximate using trapeziums. Now, what I mean by this is, can you see that, let's say, for example, there's this little curve section, and if I kind of draw this as a little highlight, that was horrible. Let's try again. If I do this, can you see that by drawing something like this, okay, that there is technically a trapezium because I've got my two parallel sides and I've got a height in between. That there's my trapezium. It gives us an approximate area. It's not very close, but it's an approximation nonetheless. Okay, so you can kind of see that this is the familiar that we were more the formula that we were more familiar with is this one here. And we've learned before H onto A plus B. And so it's kind of like this is your A, that's your B, and your H is, that H as well. Okay. So that's kind of how it is. Now, the DF and the DL just means the distance of your first kind of interval and the distance of your last interval. Okay, so that's what the DF and DL is. I'm giving you that because it's on our reference sheet, and also just keep note this little thing here. It's not a straight equals, it's kind of wiggly. It means it's an approximation. It's not exact, but it's close enough. Okay, now what they'll often say here is they'll talk about different applications. So if I'm talking about one application, essentially one application means we use one trapezium. Okay, so in this case here for one application, let's do this. Let's pretend that we've got this. And let's actually calculate it. So we know that our area is approximately H on 2 df plus dl. And so in this case here, my height is actually 6. So don't forget the height is not 5. That's the most common mistake people will make. That's actually your two parallel sides. So they are treated as your df and your dl. So in this case, it would be H on 2, and then it would be 5 plus 2. And mathematically speaking, that would be 3 times 7, which is 21 meters squared. That's an approximation. And also, it is going to take a while to get used to, but you'll probably need to remember that all of these need to be wiggly lines. Okay, they're approximate. Now, if I talk about two applications, can you see how I'm using the same shape here? But for two applications, what they start to do now is they start to talk about, okay, it's probably more accurate if we use more trapeziums. So for example, I don't know if you can see that, that's trapezium 1. And then that there is kind of trapezium 2. Okay, now I know it looks a little bit more like a rectangle technically, but let's do both of these. So for example, for the first one, I've got H on 2. Something to note here now is my new heights are now 3 and 3. Those are now my heights of each trapezium, if that makes sense. So for these two applications, we do, let's say one for the blue. We know the area for this one is approximately H on 2, 3 on 2, 5 plus 2, because you can see that that's 2 and that's 5. So sweet. And what is that? 3 on 2 times 7. Essentially becomes 10.5 meters squared. And let's check the next area, which is our green area. This area here is going to be height on 2. So again, 3 on 2 multiplied by 2 plus 2. And so this one here will end up giving us an answer of 6 meters squared. And so our approximation here, our approximation is approximately 16.5 meters squared, because I've just plus those two together, the 10.5 plus the 6. Okay, so can you see how using two applications, I should theoretically get a little bit more accurate. This one was saying roughly 21. This one is saying here it's actually probably closer to 16.5. Okay, now just to make sure you've got the right idea, let's see what happens if we now break it into 3 applications. It's still the same shape, but now we've given a little bit more information. And so we're going to break it up into those 3. I suggest pause the video and see if you can do this yourself. There's one. There's your second one. And there's your third one. Okay, so that's probably going to be as close as you can for your approximations. Keep in mind, these diagrams are not drawn to scale. So again, for this one now, if I've broken up into 3 equal parts, I know that these distances are going to be 2, 2, and 2, because they make up 6. So those there are going to be your heights for each of your different applications. So for the first application, again, practice these on your own, see how you go. But it's going to be height on 2, and then your 5 plus your 4, because that is your height of your first trapezium, your first application. So this here will be 9 meters squared. For the second one, you've got A is, I should keep writing these as squiggles. The first height is 4, the second height is 2. So again, it's going to be 2 on 2, 4 plus 2, which will be 6 meters squared approximately. Keep again. And for your last one, I apologize for the writing in yellow. Hopefully you can read it. For this one here, you can see it's just 2, 2, and 2. So here, my area for this one is going to be height on 2 times by the 2 plus 2. And this here gives you most definitely 4 meters squared. So if I wanted a approximation of the area, the total area of this little section, it's going to be 9 plus 6 plus 4, which is probably a little bit closer to 19 meters squared. Okay, now again, had I done this maybe a little bit better, 3 on 2 times 4. Yeah, that's right. 21 on 2. Yeah. Now, had I drawn this correctly, it would be pretty accurate. But again, I've just kind of drawn it off the top. So that's the idea. There's multiple applications you can do. Just keep in mind, however many applications, that's how many trapeziums you'll kind of have to draw and work with. So I hope that makes a bit of sense. All the best, and I'll catch you in the next one. See you later.